How are you doing?
Hi, how are you? I am doing well. So thanks for
Very good. Oh, no problem at all. We're very, very excited to have your talk. I'm specifically quite excited to watch yours because you are going to be talking about combining machine learning and big data and using PySpark. And PySpark's a really popular technology at the moment. Can you take it away, but do introduce yourself before you get started?
Yeah, sure. So hi everyone. I am finally a student of Bachelor's of Technology in Computer Science Engineering from Delhi, India. So apart from my daily jobs as a student at my college of where I am doing software engineering, I have a passion towards this domain of data science, AI, machine learning. And then recently I was introduced to this concept of big data. Like then I thought, oh my god, so this is another domain that I should learn, or how should I go ahead? So like my journey started from there, and I have been a frequent speaker at multiple conferences, multiple events, just to democratize the knowledge that I have and to help other students. And I also just collaborate with them so that we all as a whole can grow and can bring a change in the society. So definitely looking forward to that, and with that goal in mind, I am also here today for another talk.
Fantastic. Okay, yeah, no, feel free to take it away. So if you present your, that
Yeah.
is perfect. There we go. And then Hank will do the magic on our side. You just take it away.
Yeah, sure. So thank you. Hello everyone. So today we will be focusing on my journey that I told you that I was initially learning about machine learning, and then somehow around the beginning of 2020, I just came across this domain of big data. So I thought, now this is really challenging. Like big data deals with huge lot of like huge data, and machine learning is always data hungry, so it always requires huge amount of data, because the more cleaner, the more better data you have, the more better accuracy, the more better accurate results you have. So that's why I thought, how about combining these two? But there was another dilemma, that how should I combine, or what are the things that I should look forward to? Because till then, before starting with these big data domain, I was doing machine learning. And what happens is, like when you're doing machine learning, it's always like you try to focus upon Python, you try to focus upon R. So I thought that yes, I know Python, but how can I use that knowledge of Python in machine learning, and then I can infuse big data on top of it? So then I was just searching on the websites, and then I came across this beautiful library called PySpark. So that is one of the major tool used in the industry for combining both machine learning and big data. So I just brief introduction I just gave. So I'm currently a data science intern, and apart from that, I also brought a community called Kaggle Days Meetup in India for the first time. So it's a community where we discuss data science, we discuss machine learning, we discuss AI related stuffs. So I've divided our today's session into 6 parts. So we will start with what is big data, because like now I am assuming that we all are starting from the very basic. So I would be just giving you a definition what big data is, so that you understand what big data is or why is it actually required. And then what is machine learning, though this is a hype in the market, so it doesn't require another definition. But just to be on the same page, I have just put a definition and we'll just brief you through that. And once you understand these two, what is big data, what is machine learning, we can then understand why there was a need to fuse big data with machine learning, right? Why actually industry is focusing on that, or why even I as a student, or even you as a student, should focus on that. And then once we understand the importance, then we are at a better position to understand what is Spark. So Spark, what is that and how it started? What are the functionalities? What is the architecture? And once you understand that architecture, how that architecture will help us in doing machine learning. So definitely that part I have also tried to cover. Then once we understand how architecture of Spark would be used or would help us in doing machine learning, we will just move forward to understand a bit more about PySpark, what it is and how things work there. And then the PySpark, like how you can use PySpark and the Spark's machine learning library to do machine learning seamlessly using PySpark. And this will help us to combine both these domains, like big data and machine learning. So Big data, like as the name suggests, like hell lot of data, like huge amount of data out there. So like when we talk about big data, it's like you never know what type of data it is. Maybe it's a text, maybe it's an image, maybe it's like any type of data. So that comes to the definition that while we are talking about big data on a high level overview, it's like huge amount of data out there. But usually it's defined by four V's. That's volume, because the data is huge. Like there are multiple like petabytes, zettabytes of data out there. So volume, the scale of data is huge when it comes to big data. Then variety, like maybe it's an image, maybe it's a video, maybe it's a text, maybe it's a CSV. So you have a lot of data sources or data types, or like different types of data you can tell about. Then velocity, like IoT sensors. The previous talk we were focusing on that IoT sensors and how IoT also plays a major role into AI and related stuffs. So now you can see that when we are playing with those sensors, like you have huge velocity of data. Like there is a very high velocity of data coming in. So we have to take consideration about that. Like we have IoT sensors out there. So velocity, then variety, then volume. And the veracity is uncertainty, like situations like pandemic happens, the data goes missing, or the industry is little bit like it tries to absorb the shock of the economic recession that is going on. So the veracity, the uncertainty in the data is huge. So that was a short definition about big data, what big data is. But now as you understand what big data is and what are the four V's that defines big data, so we are at a better position now, like to understand what machine learning is. So machine learning is just a way to make our machines more intelligent, or like it's an approach to achieve artificial intelligence. Like a machine doesn't needs to be coded like every time. Like you do not have to code if else loops to do certain things. The machines can learn, the machine can act as an intelligent human. So there is a huge way to go when machines and humans intelligence comes at par. But definitely we are moving for like we are moving towards a better society where AI and humans will work in collaboration. So like machine learning, you try to make your machine learn so that it can also take like certain good decisions as an intelligent human being would have taken, right? So machine learning is that. But why do we actually need to fuse? Like now we understood what big data is. Big data is like huge volume of data, high veracity, like high velocity of data, high like everything like veracity, volume, and things like that. And machine learning is like you train your machine, you tell your machine that hey, see this, and this is how things work, and you take your approach that way. But why do we actually need to fuse these two? Like this graph is quite common that like 90% of the world's data was created in the last 2 years. So this is not a very real-time graph. So this graph was taken around 2018 or 2015, kind of like if you talk about 2015 or 16. So then it came into picture that 90% of the world's data was created in the last 2 years, while the survey was going on around 2015 or 16. So you have that huge amount of data. So how do we tackle this? So we have to bring the technologies that have been already in the market that folks used to study or folks used to research. That was big data. So we thought, yeah, big data can be a good pointer to solve this, like because we have huge amount of data. But then again, researchers in machine learning AI started taking pace that, oh, we have these much amount of data. How we can bring something out of this data, or how we can learn something better from this data. So because the world's data has creation has been huge, so we as an industry, we as students are trying to figure it out, like how we can combine these huge amount of data through a big data infrastructure, and using machine learning on top of that to derive something, or derive really cool values, or which really makes the society a better place to live, right? So that was why do we actually need to fuse what big data is, what machine learning is. But what is Spark? Like now from the name, you might have seen that PySpark, we are focusing on that. So what is Spark? So Spark is it's actually Apache Spark. So it's open source project which acts as a unified analytical engine. So like it started in UC Berkeley as an open source project, and then things like then multiple researchers came, multiple students came. They just made this platform better and better. And then industry also started contributing. Industry also started accepting it. So it like as the years passed by, it started becoming a unified analytical engine. So this is like an ecosystem. You do not have to take care about all those like how distribution takes place in big data ecosystem, or like you do not have to set up the computer from the very scratch. If Apache Spark provides you a high level analytical engine so that you can utilize it for large scale data processing. Like large scale, when we talk about large scale, it's like petabytes or zettabytes of data. And the best part why it's gaining prominence amongst the industry practitioners, like it's because of the high level APIs. A person who knows Java, a person who knows Python, a person who knows Scala or R, they can definitely jump into this wagon and can understand, can play around with the functionalities of Apache Spark. So that's the best part why industry acceptance has been high, like the high level APIs out there. And then it can also help us to execute certain stuffs using the high level tools. So when we talk about high-level tools, Apache Spark provides us with the functionalities like Spark SQL. So SQL is for those like when we used to have like databases, we used to do SQL queries, like we used to fetch our data, we used to consume data and take certain analysis out of that. So like how many employees are paid above this, or how many employees work in India, how many employees work in certain state. So like we used to do SQL queries, we used to do joins. So Spark again got prominence there because it has this high level tool for doing SQL related things. So it started with Spark SQL, then machine MLlib. So that's one of the major agenda of today, like MLlib, that's machine learning library, which helps us to do the machine learning related stuffs using the ecosystem that Spark provides. Then on top of that, folks who would love to do graph processing, they have this graphics high level tool again. And then structured streaming, like when you are using IoT sensors, maybe you are working with streaming data. So you can utilize structured streaming. So in short, this was what Spark is, a engine that helps you to do large scale data processing. And why it's gaining prominence, because of multiple APIs in multiple languages, and then this graphics, Spark SQL, machine MLlib, stuffs like that. So these are the few storage types. Like in whenever you are trying to do big data processing through Spark, it usually happens that you are trying to bring, or you are trying to store certain values in your computer, right? But how do you do that? So it started when initially Spark came, it was through RDDs. So that's resilient distributed data set. Then you have data frames, data sets. These are all kind of storage types, right? So these are few features: immutable, fault tolerant. But what happened is, because machine learning is gaining prominence and we have to work our machine learning algorithms on top of that. So industry is focusing more towards data frame. But remember, anything data frame you use or data set you use, everything boils down to RDDs at the end. So this is a storage type that Spark provides. But how Spark's architecture will help us in doing machine learning? Like this was all about Spark, but how that Spark's architecture will help us in doing. So for that, we need to understand a little bit about the architecture that Spark provides. So this is the architecture of Spark. At the very bottom, you have those big data ecosystems or the clusters like Hadoop clusters or Apache Mesos clusters, or you make a like distributed computing like a cluster of that, right? So once on top of that, you try to give a date Spark core. So Spark core contains the major functionalities of what you can do with that data, or how you try to ingest that data. So what we do, we try to ingest data from multiple sources, be it MongoDB, be it like other databases. You can ingest your data into Spark core, and Spark would take care about all those distribution, how the data is to be distributed, or how the things have to be through the Hadoop yarn clusters that you have at the very bottom, right? Once the data is inside Spark core, you can utilize the libraries that we were discussing. There is a mistake in that image. So maybe like data frames is not a library, it's a storage type. So like SQL should have come below, like data frame should not have been there. But no worries, like you can utilize, once your data is inside Spark core, you can utilize certain libraries like MLlib, graphics, streaming. So in our case, we would be focusing on MLlib. So once the data is there, we can focus on using the MLlib using Python, because let's say you are doing machine learning for a few time now, you are fluent with Python, and then you can use Python to interact with the like the data that you have in Spark core using the machine learning library that Spark provides. So this is the architecture, and this is how you can do machine learning using Spark's architecture. Like using Python, we will interact with MLlib, and which in turn will interact with the data that's stored in Spark core. So that's how architecture of Spark looks like. But how actually work is done in Spark, like why big data processing is so easy and why it's so preferred. So let's say you want to throw a birthday party. You are the driver of the event, and then you have like then you told that your brother, father, and mother that I want to throw a party to my friends. Like 50 of my friends are coming. So like you try to allot certain tasks. You told your brother to clean the house. You told your father to bring certain certain grocery items, and you told your mother to bake the cake. So you like all your mother, brother, father that are working with you are workers, and you are the driver. You know that which task to allot, which like I know that I want to throw a party, but how will I manage, or how will I do those things? I have certain workers, and they will execute their task and give back the result to me. That's through the cluster manager. So this is how Spark actions or a job in Spark works. Like a driver interacts with the cluster manager that you like I want to do this, and these are the several steps, and try to execute it through different workers. So that's how Spark provides, or like the how Spark job works. Like you make a user program, then it's converted into RDDs. Everything that you write, it's getting stored in RDDs or data frames, like anything. So at the bottom, it's RDDs. Then it makes a acyclic graph, directed acyclic graph, that this is how things should go. And then once these things are compacted, it sends those things to workers that, hey, do this task, and give back the result to me. So this is how things work. So these are a few definitions which you can look forward at later point of time. What is Spark context and what is driver executor? But how to harness the power of Spark using Python? So this is like how to use that. So you have like while we were focusing on the architecture, we discussed about the Python language that we have. But how do we actually use it? Is through a library called PySpark. So, like why there was a need to bring this was Apache Spark is actually written in Scala programming language. So it was really difficult that you try to code, try to code using Scala. While you are doing machine learning in Python, it's really becoming a little bit tough for the developers to change the languages and to do certain tasks in Apache Spark. So the Apache Spark community then thought, how about bringing something new to to make it more appealing to the Python community? So they tried to release a tool called PySpark. And once this was in the market, then the folks who were using Python majorly for data science, machine learning, AI, they tried how about using the potential of Spark, because Spark provides us a unified engine for those large data processing or for huge data processing. But again, because whenever you install Spark, you have to install Java too. So then it's because that how will my PySpark work? So it in turn depends on a library called Py4j. So that's able to do that, like whatever transactions or whatever for commands that you pass through PySpark is interacted through Py4j, and then the deal is done or the task is done. But this was all about Spark, like how like what PySpark is and how PySpark works, depending on the Py4j library that we have. But how Spark's machine learning library that we are focusing on initially, right? Like focusing on like graphics, SQL, MLlib. But how will that help? Now we know that yes, I know Python, and we have PySpark to combine, like to work in Spark. But how will actually Spark's machine learning library help us? So Spark's machine learning library, that's MLlib, already has certain high-level tools or certain high-level algorithms already there. So when we talk about classification, regression, clustering, we have all that type of algorithms already there in machine learning library. So it's another kind of scikit-learn, right? You use scikit-learn, but here you can use machine learning library of Spark and can combine and can do certain regression techniques or classification techniques. Then you have featureization, like feature extraction, do certain kind of feature engineering, and then linear algebra, statistics, data handling. You can do a hell lot of stuff. Like these are some of the major functionalities that Spark machine learning library provides. But how a machine learning workflow looks like how a Spark's machine learning workflow looks like whenever we try to do that on huge amount of data. Like let's say we are doing that on 100 GBs of data. So how does it work? Like usually what happens is when if we were to use pandas, if we were to use certain other stuffs, there would be some processing delay or stuffs like that, or our computer cannot handle that kind of data, like that huge amount of data. So we thought about a Spark machine learning workflow. So it's more or the less same like normal machine learning workflow. So here we have data frame. So we were talking about data frame. It's a storage, like where you load your data and you store your data for the time being. while you're doing the processing. Then once you store that data, so now you try to do feature engineering or try to reduce certain features, try to make new features, right? So that's transformer. So transformer means like you get certain features and you transform them, be it by reducing, be it by making new features. You try to you try to make new features or reduce some features. That's more into feature engineering kind of stuff, right? Once you're done with that, then you come through estimator. So what estimator does, it takes certain feature like the certain columns that you have and runs a algorithm, runs a model on top of that, like runs algorithm. Let's say it runs a linear regression on top of that. And at the end, what estimator does, it accepts certain features like in the form of transformers, like transformer transforms those features and then give those features to estimator. And then estimator in turn makes a model out of it, right? So estimator makes a model, and then we have evaluator, how our model is performing. We check the accuracy, we check our certain other stuffs with regards to that. And at the end, we on the left hand side, you can see that this is training, and then we can do fit, and then we can do the same thing on testing, like how our model is performing or on the testing data set that you have. So similar like normal machine learning workflow, but definitely it's really useful when it comes to huge amount of data, like you have gigabytes of data, like 100 gigabytes of data to play with. So definitely a Spark machine learning workflow fits in there. These are the few definitions, like data frame. So data frame is like again a storage kind of stuff. Transformer is like it takes certain features and makes like it transforms and makes certain new features, makes a new data frame out of that. Estimator takes a transformer and transforms it into a model and produces a model. Then pipeline is like the step-by-step process. Like first I will do data cleaning, then I will do data feature engineering, I will do this, like certain steps, so that you do not have to repeat it again and again. So pipeline just gives you that flow. So this is a pipeline, like loading data. Then you have string indexing. You index the strings. Like these are certain steps. Like stage one, I should do this. Stage two, I should do this. Stage three, I should do one hot encodings. And stage four, I just do the vectorization. And then as the stage five, I make a logistic regression model. And the end, we get a predicted label, right? We are trying to do, let's say, classification. So we are trying to use this algorithm or try to use this pipeline to get to the end results. Then again, like as we at the initial of this MLlib, what MLlib provides, we were discussing about variety of regression, variety of classification problem that it provides us. But these are a few algorithms that you might have heard like too much, heard regularly in machine learning classes or machine learning courses. So definitely Spark's machine learning library, MLlib, provides you with all those things. SVMs, you have linear regression, lasso regression, like then you have naive Bayes, PCA, and singular value decomposition. So Spark's machine learning library has got you covered with a hell lot of algorithms already out there. And even if you were doing machine learning using Python, now you have PySpark, and now you can utilize the architecture of big data. You do not have to take care about how the distribution of data would take place in the background, or how the clustering is done, or steps like that. So Spark provides you the architecture, perfect architecture to play with huge amount of data. And machine learning is data hungry. So you utilize once the data is in big data ecosystem, you utilize that data to do your machine learning. At the end, it's definitely a good definitely a good thing to explore new stuffs and how you can combine these two. And really the industry is gaining super it's gaining the like how combining machine learning and big data is gaining prevalence in the industry is really exciting, and it would really fetch you certain real world applications, real world projects if you want to do. So these are a few useful resources. So maybe these are the documentations or the official documentation of Spark. So you can find them, and it's definitely useful to read them because it becomes a little bit easier for you to go through them and to understand, to learn things better. So yes, like now it may sound a bit daunting that how machine learning or how big data would go, or how would I do those things, because machine learning itself as a domain is a little bit tricky and you have to do certain mathematics and stuffs like that. And on top of that, how would I do big data? So don't worry, you do not have to be a master of big data, or you do not have to be a master of machine learning, like a super cool master of those both domains. No, you're not required to be that, but definitely a little bit knowledge about machine learning libraries or machine learning algorithms, how it works and how you can make the code optimized. and then big data ecosystem, a little bit of big data ecosystem, how these things how these things work, how clusters work, cluster manager, driver, and the workers that we discussed, how they work. Definitely a short, a brief knowledge about those things would be definitely easy. Would definitely make it easy for you to combine these two. So in case you have any questions, do let me know. I will try my best to answer them. And in case you have any feedback or you would love to connect with me on LinkedIn, so like I have this Ion, I have a username like that's IonRide2000. You can connect with me on LinkedIn, or you can just get in touch with me through Telegram, and I also have a GitHub profile. On top of that, if you want to mail me, that's I would be super happy to help you through mail. That's ion.roy2000@gmail.com, or you can visit my personal website, ionroy.ml. So thank you, and I really hope that I was able to do those things.
Excellent. Thank you so much, Roy. So there is one question in the chat, like how do you organize project development and version control and deployment in the context of a company using Spark? So if you have a large project with a lot of assets, how do you manage that?
Yeah, so like how we actually manage was we have usually what happens is on AWS there is certain called there are certain ecosystem that AWS already provides, like that's EMR, Elastic Map Reduce. So you do not have to take care about how those things are managed there, or you do not have to take care about those things. So being on cloud definitely gives you an advantage. And when it comes to version control, it's not always that we version control the data. It's always like the models that we are training, and we try to hyper tune we try hyperparameter tuning and stuff like that. So we try to put those things into our into the version control, so that we can keep a track over the performance and monitor those things, like how things work and how we can keep a track of those things. So definitely, like at a industry level, it works like that.
Right. Thanks for mentioning the cloud. Actually, when it comes to Apache Spark, you run this on clusters, and if you were to set up the cluster on premise, that would require some significant engineering work. But in the cloud, there are tools like Databricks, which is essentially managed version of Apache Spark, which in terms of ease of use, it's just like you create the Databricks, and it gives you the Jupyter notebook where you can start typing your code. You don't have to think about managing the cluster. It even starts and stops the cluster automatically. So it becomes very easy to start using indeed Apache Spark on the cloud. Also, we've made a poll, and it looks like a lot of people from the audience, they are new to Apache Spark. Can you maybe quickly mention what kind of tasks? I mean, it's clear that it's big data, but maybe just an example of how do you use machine learning for big data, for what kind of problems?
Yeah, so like what happens is I will just give you a brief real world introduction, like how industry uses. So you might have heard about Uber, like Uber have this how they connect you with the drivers, like the drivers that are operating in your place, how they connect. And they have a hell lot of data, like there are multiple cars that are operating in the state, in your city. How do they operate? Or like now you gave you might have also heard the concept of surge pricing, right? But how actually Uber does that? So for surge pricing, they have to take into consideration the amount of data that they get, like how many cars I have in that area, or how many folks are demanding cars, like how they behave, like how they get to know that this is at this point of time I should do I should do surge pricing. How do they decide? So it's through that big data, like because they have huge, like thousands and thousands of car out there, and lakhs of customers who are trying to get a car for themselves, right? So you have these huge amount of data, and like Uber as a whole is using this in the real picture, that how they're connecting you with the driver partners out there. So big data is one of the biggest example that you can see in the real world.
Yeah, that's really a great example. So there are also a lot of questions asking to provide the links to resources. So please provide your links like to us, and we'll share it at the resources page. Or maybe some very important links you can provide as the answers to in the chat. Thanks again for your talk. And the next talk is by Sami Depres, who is one of the leaders of